Okay, the next section of trig, this goes along with the tangent, it just follows it in succession, is the sine and cosine. Okay, on your calculator it looks like sin and cos, but I want you to say sine and cosine. Okay, so the first thing you need to know, the sine is the leg opposite A over the hypotenuse. So now we're not actually going to use the hypotenuse. And the cosine is the leg adjacent over the hypotenuse. So then if we're looking at just angle A, this is the opposite, this is the adjacent, this is the hypotenuse. Okay? And it helps to label them as such. Put an A and an O and an H on there. Okay? So there's this thing, and it's called SOHCAHTOA. And it kind of helps you figure out what you're using here. Okay? SOHCAHTOA. S is sine, O is opposite, H is hypotenuse. So sine is opposite over hypotenuse. C is cosine, adjacent hypotenuse. So cosine is adjacent over hypotenuse. And then T is tangent, and then opposite over adjacent. So this little saying, you'll hear me say it a lot, and a lot of people write SOHCAHTOA across the top of their paper automatically, so that you can look at it and you can figure out which one you're using. Because I'm going to give you triangles and say, how do you do this? Is it sine or cosine or tangent? And so you have to figure out whether it's sine or cosine or tangent. So that's kind of tricky. Okay? Also, there's this little, they call them trig identities. This is one of the identities. Okay? Tangent equals sine over cosine. Because the tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So then we all know that if you divide by a fraction, you multiply by the reciprocal. So you see what happens? H's cancel out, left with opposite over adjacent, and that's what tangent is. So that's the proof of the identity. Okay? So this is a little helpful hint. Maybe not so much in here, but if you take anything above Algebra 2, then you might see that again. Alright, so let's go play with this and see if we can figure out how to do this. Alright, sine of t. We're going to start with t. Okay? From t, this would be the opposite, this would be adjacent, this would be hypotenuse. Right? So for t, we need the opposite over the hypotenuse. And then cosine of t, we need the adjacent over the hypotenuse. Okay? It's not too bad. These are just the ratios. If I want a ratio, I just want a fraction. That's a ratio. Now, let's look at g. For g, this would be opposite, and this would be adjacent, and this would be hypotenuse. I'll put it in a different color so you can see the difference. Okay, so sine of g, we're going to do opposite, so that's 15 over the hypotenuse. And then cosine g, we're going to do adjacent, which is 8 over the hypotenuse. Now, look at what you see right now. You see that the sine of t and the cosine of g are the same, and you see the cosine of t and the sine of g are the same. And that is a thing. That's another identity that eventually you'll see in trig. But this does happen. The sine of one and the cosine of the other are the same value, the same ratio. Okay? And that's why it comes out to be the same angle when we go to solve. Alright, let's do it again. Sine of x. From x, this is opposite, so that's 64, over the hypotenuse is 80. And then cosine of y. Remembering what I just said, you should know what this is going to be. But you do adjacent, which is 64, over the hypotenuse. Cosine of one, sine of the other are the same value. Okay? Alright, let's go do some math here. Find the measure of angle L to the nearest degree. Finding degrees, you're going to hit the second key in order to do this in your calculator. Okay, so let's say I wanted to do sine of L. So then I would do opposite over hypotenuse. But then somebody else says, well, wait, I want to do cosine. So then cosine would be adjacent, which is 2.4 over hypotenuse. And then even a third person says, I'm going to be difficult and I want to do tangent. So they do opposite over adjacent. Now, tell me, does it matter which one of these you use? Because if we start putting this in our calculator, for the sine up here, we'd hit second sine, 3.2 divided by 4.0. I get 53 degrees. For cosine, I'd hit second cosine, 2.4 divided by 4.0, and I get 53 degrees. For tangent, I hit second tangent, 3.2 divided by 2.4, and I get 53 degrees. So does it matter which one you use as long as you have all three sides? It's a good question to think about. Just make sure that you pick one and just do it. You just have to make sure you have enough to do it. Alright, find the value of x. Now here, I don't have all three sides. So I have to kind of work with what I've given unless I want to find the third side and then work through everything. So from the x, 6.5 is the opposite and 10 is the hypotenuse. So then we look at SOHCAHTOA. I told you you'll write it on your paper a million times. Okay? And we look at this and we say we have an opposite and a hypotenuse. Which one is it? And it would have to be the sine. So we're going to do sine x equals opposite over hypotenuse. And since we're looking for the angle, we're going to hit second sine, 6.5 divided by 10, and you get 41 degrees when we round it to the nearest tenth, or nearest degree, sorry. Okay. This all of the math is the same, you just have to figure out whether it's sine or cosine or tangent. Alright, one more. Here's my x. So when you look, the 10 is the opposite. 27 is the hypotenuse. So in SOHCAHTOA, then that has to be sine because it's opposite and hypotenuse again. So we do sine x equals opposite over hypotenuse. Put it in your calculator, second sine, 10 divided by 27. That would be 22 degrees. Now would be a great time to tell you that if you don't have your own calculator, it might be a wise idea to get one like the ones we have at school, because your phone is not necessarily going to do everything we need it to do. And when you take a test, you're not going to be allowed to use your phone. Okay? So it might be a good idea to get your own calculator at this point. Alright?